Hello friends, I welcome you in lecture number 43 on logic. In this lecture we are going to discuss one question on determining the validity of argument. This question was asked in GTU Summer 2021 examination. First we understand what is given argument and then we will try to determine its validity. The argument is, if I study then I will not fail in discrete mathematics. If I do not play cricket, then I will study. But I failed in discrete mathematics. Therefore, I must have played cricket. So, as we know that whenever we want to determine the validity of given argument, first we will consider notations for different propositions in the given argument, and using those notations we will try to write given argument in symbolic form and then we will check its validity. So here we can see that there are three propositions. One is I study, another we can consider as I will fail in discrete mathematics, and next we can consider as I play cricket. So we can denote this I study by small p. We can denote I will fail in discrete mathematics by q, therefore this is negation q, and we can denote I play cricket by r, therefore this is negation of r. So first we have to write down which notations we are using. So as I discussed, I denote this proposition I study by small p. I use q for this statement I will fail in discrete mathematics, and r denotes that I play cricket. And then using these notations we are able to write down these premises in symbolic form. First one is if I study, that is p, then I will not fail in discrete mathematics, that is negation q. So first premise in symbolic form is p implies negation q. Second is I do not play cricket. I play cricket is denoted by r, therefore I do not play cricket is denoted by negation r, and here then I will study. I study is denoted by p, so this premise in symbolic form is negation r implies p. I failed in discrete mathematics, so that is nothing but small q. We have used the small q for I fail in discrete mathematics. Therefore, I must have played cricket. We have denoted by r this proposition I play cricket. Therefore, here we have small r. So these three are premises. P implies negation q, negation r implies p, and q, and this is the conclusion. So using this symbolic form of given argument can be written as P implies negation q, negation r implies p. P implies negation q, negation r implies p, and r. So negation r implies p and r, and what is conclusion? Here we have q and conclusion is r. P implies negation q, negation r implies p, then q and r. So here I have to write r, and here premise is q. So this is symbolic form of given argument, and we have to determine the validity of this argument. So there are two ways to determine the validity. One is you can use truth table, and another way is you can use standard rules of inference, and you can arrive at the conclusion using these premises. So first we determine the validity using rules of inference, and we will use truth table to determine the validity also. So we are doing this question using two methods. Here they have not specified anything, so if you wish you can use rules of inference to check the validity of this argument. or you can use truth table to determine the validity of this argument. We are going to determine the validity using both the methods. So first we are considering the method of using rules of inference, and we know that in that method we write down our proof as a 2-column proof. In one column we write statements, and in the second column we write down the corresponding reasons. So first we start with first premise, which is P implies negation Q. So here I am writing premise, and I will keep in mind that I want to arrive at conclusion R. Here I have P implies negation Q, and here I have negation R implies P. So if we check contrapositive of this, then I will have Q implies negation P, and contrapositive of this will be negation P implies R. So what I can do is I can write down this premise, then I will write its contrapositive, then I will write down this premise, then I will write its contrapositive, and for these two I will use hypothetical syllogism. So in this second step I am writing contrapositive of 1. Contrapositive of 1. So negation contrapositive of P implies negation Q is negation of negation Q, which is Q implies negation of P. Then I am writing second premise, which is negation R implies P. Negation R implies P. This is our premise, and we write down contrapositive of negation R implies P, which is negation P implies negation of negation R, that is R. So here we have taken contrapositive of statement 3, and now we observe step number 2 and 4, and we can see here we can use hypothetical syllogism. So our reason is hypothetical syllogism on statement number 2 and 4, and here I have Q implies negation P, here I have negation P implies R, therefore I must have Q implies R using hypothetical syllogism. And the next premise we have not used is small q, so now we use that premise. Here I am writing Q here, so I will obtain, I am using premise, so I have written premise in this column of reason. Now you can think about modus ponens. Here I have conditional statement, and here I have hypothesis of this conditional statement. So using modus ponens, what we will obtain here? R. So here we have to write that what we are applied modus ponens on statement number 5 and 6, and we arrived at conclusion R. So this proves that given argument is valid. Therefore, using rules of inference, we are able to prove that given argument is valid. So this is one way to determine the validity of given argument. So if you wish, you can use this method, and if you wish, you can use truth table also to decide the validity of given argument. So I am using truth table now for the same argument form. I have written that argument here. P implies negation Q, negation R implies P and Q. These are the premises, and conclusion is R. Now in the use of truth table, what we are doing, using truth table, we can say that this argument is valid if conclusion is true whenever all premises are true. Whenever all premises are true implies that conclusion is also true, then we can say that given argument or argument form is valid. So in this method, first we have to prepare the truth table, and first we have to decide the number of propositional variables in given argument. Here we have 3 propositional variables p, q and r. So we will have 2 raised to 3, that is 8 different possible combinations for the truth values of these 3 propositional variables. Then we will write down the columns in the truth table corresponding to all these premises and conclusion. Conclusion is one of these variables, that is r. After that we will search for those rows in the truth table in which all these premises are true simultaneously, and we will check the corresponding truth value of r in that column. So whenever all these premises are true implies that r is also true, then we can say that our argument is valid. And if that does not happen, that is if we can find out at least one row in which these 3 premises are having truth value true but r is false, then our argument is not valid. So first we prepare the truth table. We know that if we have 3 variables, then we write in this way different possible combinations for truth values. So for p I am writing first 4 true and then last 4 false. Then for q we are writing 2 times true and 2 times false, t, t and f, f. For r we write down alternately true and false, t, f, t, f, t, f. And we have to be careful, we should not make any mistakes. Here I have negation q, so that is opposite of truth values of q. Here I have 2 times true, therefore I will write 2 times false. Here I have 2 times false, therefore here 2 times true, then 2 times f, 2 times t. Similarly here we have negation r. Here r start with t, so negation r will start with f, alternately true and false, f, t, f, t, f and t. Now here I have to write down p implies negation q. So this is column for p, this is column for negation q, and we know that this type of conditional statement is false whenever p is true and negation q is false. In all other cases it is true. So in the first row p is true and negation q is false, therefore truth value is false. In the second row p is true, negation q is false, therefore we have false here. Here p and negation q both are true, therefore true. Same thing here, both are true. And in this last 4 cases p is false, so we don't have to worry about truth value of negation q, we will simply write true here. Again I emphasize that conditional statement is false whenever this first variable has truth value true and second variable has truth value false. In all other cases it is true. Then we have negation r implies negation p. So here also this is false whenever negation r is true and p is false. So we will check for negation r and p. This is for negation r and this is for p. So we will first check for negation r. Here negation r is false, so we don't have to worry, we can simply write true. Here negation r is true, therefore I have to check for p, it is also true, therefore I have true here. Then here negation r is false, so we can directly write true. Here negation R is true and P is also true, therefore here true. Here negation R is false, therefore this is true. Here negation R is true and P is false, therefore we have false here. Then negation R is false, so don't worry about this. Here true and this is false, therefore we have F here. We again check for this negation R and P. This is false if negation R is true and P is false. So we start with negation R again. Here negation R is false, so I will write true directly. Here negation R is true and P is true, therefore this is true. Then negation R is false, therefore this is true. Negation R is true and this is also true, therefore true here. Negation R is false, therefore this is true. Negation R is true and P is false, therefore this is false. And this I have checked. Then negation R is false, so this is true. Negation R is true and this is false, therefore we have F here. So we have written all columns required for the method. Now what we will do, we will concentrate on these premises which are P implies negation Q, negation R implies P and Q, and we will find out those rows in which these premises are true at the same time. P implies negation Q, negation R implies P and Q. So first we check for first row. In first row Q is true and this is false. Then we check for second row. In second row also all are not true. In third row Q is false. In fourth row Q is false. And in fifth row all are true. Q is true, then P implies negation Q is true and negation R implies P is also true, and conclusion is R. So we can see that R is also true. So in row 5 we find that whenever premises are true, R is also true. Then in row number 6 Q is true but this is false, so we are not interested in row 6. Then in row 7 Q is false. In row 8 Q is also again false. So there is only one row in which this premises P implies negation Q, negation R implies P and Q are true, and corresponding value of conclusion R is also true. That means whenever premises are true, conclusion is also true, therefore given argument is valid. So we can write that in row 5 we observe that whenever premises are true, so in that case conclusion is also true, and this is the only row in which this happens. So this means whenever premises are true, conclusion is always true, therefore given argument is valid. So this is another way of determining validity of the same problem using truth table. So now you have two methods. You can use which method is comfortable to you. The method of truth table becomes tedious or uncomfortable when this number of variables are greater than 3. Here we have only 3 propositional variables, therefore there is no problem using truth table also, but when number of variables increases, the method of truth table is not comfortable, and we should use this method of rules of inference, and that is also quite easy. So this is all about this session. I hope you like it. Thanks for watching.